Assalamualaikum warahmatullahi wabarakatuh and good afternoon. So today we're going to continue on chapter 5 about the magnetic coupled circuit. So this is the third subtopic, basically linear transformer. So let's look into it. So what is linear transformer? It is generally a four-terminal device comprising two or more magnetically coupled coils. So basically, if you look at this figure here, this is a linear transformer. There's a four terminal, so 1, 2, 3, 4, and then we have a coil, which is the inductor L1 and L2 and L2. So at least it has two inductor or maybe more. Okay, so we have a primary coil and a secondary coil. So to find the reflected impedance, which is the Z in here, we can use this formula where Z in is equal to R1 plus JWL1 plus ZR, or where ZR here is the equal to omega 2 square M square divided by R2 plus JWL square plus ZL. Okay. So in linear transformer, we can create an equivalent circuit from this basic circuit here. So we can convert it to T circuit, equivalent T circuit, which is this shape circuit, T-shaped circuit, and also pi circuit. Okay, equivalent pi circuit. So how we can convert from this value to LA, LB, and LC? We can use the formula that I will show you after this. LA, so this is a small capital, and this is capital letter, and this is small letter. Okay, let's look at the so to find the formula for LA, LB, and LC, you can use this. You can check in the what we call books AC circuit, page 542. So LA is equal to L1 minus M, LB equal to L2 minus M, and LC equal to M, where the capital for this is for the for the T equivalent T circuit. This is the formula, and for the pi equivalent circuit, this will be the formula. So for pi, they use a capital letter here, LA, LB, and LC. Okay. So let's look into this example. In this circuit below, calculate the input impedance and current I1, which is at the primary coil. Take Z1 equal to 60 minus J 100 ohm, Z2 equal to 30 plus J 40 ohm, and ZL, which is this over here, is equal to 80 plus J 60 ohm. So we have J1 as Z1, Z2, and ZL, and they also give the value for L, JWL 1 and L2, and also they give the value of M here. Okay, so let's look into the answer for this example. So this is the answer for the example 13.4. So if you look at this, they just use the formula that I already given to you, Z in, where Z in is R1 plus JWL1 plus W square M square divided by R2 plus JWL2 plus ZL. So they just use the formula. So if you look at this, they insert the R1, which is the Z1 over here. So 60 minus J 100 ohm, and then for the JWL1, so basically this is the value L1. So we have here is L1 and this is L2. So they just insert J20. And then for the ZR, so if you look back at the slide, so ZR is equal to the formula is a bit this is the formula. So we have W square M square. So the W is not given here, so I presume that this example assume that the value is 1. So 1 square get 1, and then we have the value of m 5. So they get the value over here, square divided by j40. So j40 is the JWL2, so over here. And then for the R2 is the Z2, and for ZL is the ZL. So just insert the value Z2 and ZL inside of the equation. So you will get Z in equal to 100.14 angular minus 53.1 ohm. And to get the current I over here, we just use the formula V equal to IR, where V is the value of the voltage source, 50 angular 60 degree, and divide by Z in over here. So you will get 0.5 angular 113.1 degree ampere. Okay, so you get I1. So for practice problem 13.4, you can try to solve this. It's the same as the previous example. How to solve it? You need to find the input impedance and the current. So the current means the current at the the primary coil over here. Okay, so the value is also given m L1, L2, Z1, Z2, and Z load. So I think it shouldn't be any problem. We try to answer it, and the answer should be, you will get this value. So Z in equal to 8.58 angular 58.05 ohm, and I1 current at the primary coil 2.331 angular minus 58.05 ampere. Okay, now let's look into the ideal transformer. What is ideal transformer? An ideal transformer is a unity coupled lossless transformer in which the primary and secondary coil have infinite self-inductor. So this ideal transformer is a lossless transformer. Usually the transformer have losses, but this is to make it easier for you to understand. We will discuss only the ideal transformer. So the formula that you need to know is, first is this one, where the voltage V1 and V2, V1 over V2 is equal to N2 over N1. So N is the number of winding or turn of the coil at the secondary coil. N1, this is N2, N1 is the same, so it's the number of turn of the coil. And voltage V1 and V2 is over here, over the voltage across the inductor. Okay, so V1 and V2, so don't confuse with the voltage over here. If there's no resistor at this part here, means that V1 is equal to V. However, if there's a resistor or inductor at this point over here, so you need to use voltage division or voltage divider, and also it is equal to N. And if you look at the current, so current is opposite, where I2 over I1 equal to N1 over N2, so it's opposite of the turn. Okay, and it is equal to 1 over N. So if V2 is larger than V1, we call it step up transformer. If it's V2 less than V1, we call it step down transformer. So now let's look at the 4 circuit here. So what's the difference between this circuit is the dot terminal over here. So you need to have to look at the dotted. If is it going out, the current is going out, or going in to the dotted terminal. So this is the normal condition, where the current is in the primary coil, I1 is going into the dotted terminal, and at the secondary coil, the I2 is going out of the dotted terminal here. So the equation used is the same. However, if you look at this, if I2 is going inside, both is going inside into the terminal, means that we have to use this equation over here. If you look at the equation, you can see the difference is the what polarity. There's a negative here, so the current will be negative. Okay, and then if you look at this part, the dotted is at the negative at this part. One is going in, then I1 is going out, and I2 is going in. So this the voltage here will be negative. However, if you look at this, the dotted is at the negative at the secondary coil, and the terminal, the current is one is going in and another one is going in. Okay, both are going in. So however, the terminal is opposite, so both will be negative. So we have to look at the dotted terminal and refer when if there is a question in test or final exam, please refer to this figure first and look at the dotted terminal and also the current flow and use the correct formula given. Okay, let's look at this example 13.7. An ideal transformer is rated at 2400, 120 volt, and also 9.6 kVA, and has a 50 turn on the secondary side. So we need to find the turn ratio, the number of turn of the primary side, primary coil, and the last is the current rating for the primary and secondary winding. Okay, so for this we have to look at the answer. So this is the answer for the question. So what actually, if you look at the question, you see that it mentioned here 2400/120 volt. So this basically is the voltage in the primary and also at the secondary coil. So for V1 is 2400 volt and V2 is 120 volt. So if you look at this, the value of V1 is much larger than V2, so it is basically a step down transformer. And to find the turn ratio, we can use this equation, n equal to V2 over V1, so that you get 0.02. And they also ask, and the second question, which is B, they ask to find the number of turn of the primary side. Okay, so we already know that the secondary side, okay, also the secondary coil has a 50 turn. Okay, over here, so we can use this equation where n equal to n2 over n1. So we already know the value of n here, so the n1, which is at the primary coil, will be 1010. And to find the current of each primary and secondary circuit or coil, we can use the equation for the apparent power, S equal to V1 I1, and also S also equal to V2 I2. And the question already give the value of the apparent power, which is 9.6 kVA. So from there, we already know the value of V1 and V2 and V1. So we can get the value of I1 and I2 using this equation. Okay. So for the next question, practice problem 13.7. So it gave the value of voltage V1 and V2, and also they give the current flow. So basically this is the current flow at the primary side, and then they asked to find turn ratio, kVA rating, and secondary current. So basically you can use the same formula that we did from the previous question, and please try this example, and the answer will be this over here. So please try and try to get the answer correct. Okay, so I think that's all for this chapter 5, magnetically coupled circuit. We will discuss more in tutorial where I will discuss on the few questions on this chapter. So see you on Tuesday. Okay, Assalamualaikum and have a nice day.